Good morning, children. This is class 12th physics. Today we are going to start with the ninth topic of chapter number 1, that is electric forces and fields. The topic is dielectric constant or relative permittivity, right? So, dielectric constant of a medium or relative permittivity, it is represented by the symbol that is epsilon r, that or it is epsilon r, or the symbol can be used as k, right? So dielectric constant or relative permittivity, the children, that is the ratio of absolute permittivity when the charges are in a particular medium to the absolute electrical permittivity when the charges are in free space or they are in air, that is vacuum, right, children? So when the permittivity of free space or air or vacuum, it is denoted with the suffix epsilon naught, right? That is 0. So epsilon r, that is relative permittivity, it is the ratio of epsilon, that is in a particular medium, upon epsilon naught, that is in free space, or it is in air, that is in vacuum. So it is the ratio of absolute permittivity in a particular medium upon the absolute electrical permittivity in free space. Now, children, this absolute permittivity, it only depends upon the nature of the medium, right? It does not depend upon any other factor, right? Now, children, we have done Coulomb's law. So, children, according to Coulomb's law, we can write the force, the magnitude of force between 2 point charges, that is Q1 and Q2, and let the distance between them be r, right? So, let the distance between them be r, and they are placed in vacuum. So children, in vacuum, the permittivity, the relative permittivity or electrical permittivity is epsilon naught, right, children? So we know the formula, that is F equals to 1 upon 4 pi epsilon naught, because the charges are placed in vacuum, and the electrical permittivity in vacuum is represented, it is shown by symbol epsilon naught. So it is 1 by 4 pi epsilon naught. Q1, Q2 are the two magnitude of the charges upon square of distance between them. So distance between the two charges is r, so it is r square. Now children, the same charges which are kept at the same distance are, but instead of the vacuum medium, you are having some other medium. So now the force between the two charges placed at the same distance r, but the medium is different. So will be given by 1 upon 4 pi epsilon. See, epsilon naught was for vacuum, for free space, but this is for some other medium, that is epsilon, into Q1, Q2 upon r square, right? So this is our equation 1. This is our equation number 2. What we are going to do is, we are just going to take we are going to divide equation 1 by 2. So dividing equation number 1 by 2, what we are going to get, children? We will get force in vacuum upon force in medium, that is 1 upon 4 pi epsilon naught Q1 Q2 upon r square upon 1 upon 4 pi epsilon Q1 Q2 upon r square. Q1 Q2 upon r square will get cancelled. 1 upon 4 pi, 1 upon 4 pi will get cancelled, right? What you will be left with is 1 upon epsilon naught upon 1 upon epsilon, right? Which is equal to epsilon upon epsilon naught. So this ratio, that is epsilon by epsilon naught, that is, it is the permittivity in a medium upon the permittivity in the free space. This ratio is known as the relative permittivity, which is shown by the symbol epsilon r, or it is also called the dielectric constant K, which is equal to the electrical permittivity in a medium epsilon upon the electrical permittivity in the free space, that is epsilon naught, which is equal to F vacuum upon F medium. So this constant is known as relative permittivity or dielectric constant. So children, if you want to define this relative permittivity or dielectric constant, you can define it as ratio of force. Ratio of force of interaction between two charges which are separated by a certain distance in vacuum upon the force of interaction between the same point charges kept at same distance, but this time they are in some particular medium, right children? So now if we make F medium the subject of formula, then if we make F medium the subject of formula, then it will be F medium equals to F, that is force when the charges are held in air, upon epsilon naught. What we have done from this, we have made F vacuum. From this we have made, that is F medium the subject of formula. So you will have F vacuum upon epsilon R. Okay, so this is your definition for dielectric constant of a medium. So dielectric constant is defined as the ratio of force of interaction between two charges which are kept at a particular distance in vacuum upon the force of interaction between the two charges, same charges, which are kept at the same distance, but they are kept in some particular medium this time. So this ratio is known as the dielectric constant, K, or it can also be called as relative permittivity, that is epsilon R. Right, so epsilon R, it depends upon the material, and the values of epsilon R for different mediums I have shown it over here. That is for vacuum it is 1, and for air it is 1.0006. So near about for vacuum and air it is same, right? And the relative permittivity for water is 81, and for metals it is infinity. See children, here we are not having the units because it is just the ratio of two permittivities, relative permittivity, right? And this is the absolute permittivity, relative permittivity for few more materials. Now let's start with numerical one. What is the dimensional formula of charge? Now you know the formula I equals to Q by T. As you want to find the dimensional formula of Q, Q is IT. Now you know the dimensional formula of charge. You have to find for charge, you know for current. Current is ampere. Dimensional formula of current is ampere, that is A raised to 1. And time, you know, it is T raised to 1. So dimensional formula of charge is AT. Right? Next is dimensional formula for epsilon naught. So you know, according to the Coulomb's law, the formula is F equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. From this we will make epsilon naught subject of formula. So epsilon naught is taraf chala jayega and force will come down in division. So you will have this formula, that is epsilon naught equals to 1 by 4 pi F Q1 Q2 upon R square. Right children, epsilon naught equals to 1 upon 4 pi F Q1 Q2 upon R square. Now we know the dimensional formula for charge. क्या होता है? Coulomb, right? अभी हमने ऊपर find किया, that was 80. So dimensional formula of charge is 80. That Q1 का dimensional formula हो गया. Dimensional formula for Q2 is again 80, and dimensional formula for force, we know it is M1 L1 T minus 2. And R square, R is what? It is length square. So it is L to the power 2. So when you simplify, you will get the dimensional formula for epsilon naught. That is the electrical permittivity in vacuum. That is M raised to minus 1, L raised to minus 3, T raised to 4, A raised to 2. So this is the dimensional formula for epsilon naught. 2 marks question can be asked in your exams, Right, beta? Okay. Next, let's move forward. This is your numerical number 3. Let's read the question. Two small spheres, each carrying a charge q, are placed at r distance apart, repel from each other with the force F. So these are two small spheres, right? Each is having a charge q and the distance between them is r, and they are repelling, they are moving away from each other with the force F. If one of the sphere is taken around the other in a circular path, if we move one in a circular path around the other, find the work done. So children, when you are moving one charge in a circular path around the first sphere, at that time, the angle between the force and the displacement, the force and the displacement will be 90 degree, right? For example, this is one charge and this is other charge you are moving, right? So this force is acting like this and the displacement is perpendicular to it. So they are acting at an angle of 90 degree. So we know the formula for force, the work done is force into displacement, right? But it is F dot D. So it is FD cos theta, and theta is 90 degree. When you put cos 90, it is 0. So no work is done in this case, right? Now, next children, you are having numericals. We are done with numericals, right? Now we are going to start with, that is your Coulomb's law in vector form. Coulomb's law in vector form. So this is topic number 10, that is Coulomb's law in vector form. Right? Let's start with this. So here we are having two positive charges. One is Q1, the other charge is Q2. They are placed in vacuum at point A and B. Right? Now, here R1 is the position vector of charge Q1 with respect to origin. Origin से उसका position vector क्या है बेटा? R1. Similarly, the position vector for charge Q2 with respect to origin is R2. So here we have considered two positive charges Q1 and Q2 which are placed in vacuum at point A and B. And let R1 be the position vector of charge Q1 with respect to origin and R2 be the position vector of charge Q2 with respect to the origin. Right? Now, next. Now, in vector form, if we want to give the Coulomb's law gives you the magnitude of the force between the charge, right? So let's find out the force on Q1 by Q2, right? So it will be represented by F12 with a vector sign. So F12 is what? Force on charge Q1 by charge Q2. So we know the Coulomb's law formula equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. But यहाँ पे हमें vector form में लिखना है. So we need to put direction. So for direction, we are going to initially put the unit vector. Right, children? Unit vector. So here we will put the unit vector, that is F12 is the force on charge 1 due to 2, that is 1 upon 4 pi epsilon naught Q1 Q2 upon R12 square. R12 is the position vector from charge 1 to 2. 1 से 2 का जो position vector है, that is your AB, that is represented by R12, that is the distance between them. right? And here we want to show it in vector form. So here we are giving the direction by putting r12 cap. Here this is a unit vector. This indicates the direction, that is it is from charge q1 towards charge q2. The direction is from q1 to q2, right? In grade 11th we have done unit vector. It can be shown by unit vector can be shown by vector upon its magnitude, right? So your unit vector is r12. So r12 can be written as vector r12 is vector r12 upon its magnitude, that will be equal to unit vector r12. So instead of unit vector r12, we can put vector r12 upon the magnitude, that is simple r12. But already you are having r12 square, so it will become cube. So children, this is the vector form of Coulomb's law, that is F12 is equal to 1 upon 4 pi epsilon naught q1 q2 upon r12 ka cube into the direction of the vector is r12 vector. Right, children? Here R12 is what? Here R12 is R1 minus R2. Vector R1 minus vector R2. And if you do cube of it, it is the cube of the magnitude. So magnitude ka cube. Similarly, children, we want to find out the force on charge Q2 due to Q1. So it is F21. So you will have F21 equals to 1 upon 4 pi epsilon naught Q2 Q1, that is Q1 Q2 is same upon यहाँ पे F21 था, so here you are going to have R21 का square, and here it is F21, so here it is unit vector R21. But unit vector R21 can be written as vector R21 upon the magnitude. So magnitude already पहले था square and it will become cube. So here you are having the cube and here you are having the direction also. So this is your Coulomb's law in vector form. So here R21 is nothing but it is vector R2 minus R1. And if you do cube, it is magnitude ka cube. Right? So if you look very carefully, then children, these two equations we know from the Newton's third law of motion. We know from Newton's third law of motion that action and reaction, they are equal and opposite, right? So here one force is action, other force is reaction. So moreover, we know that the unit vector R21 is equal to minus R12. R21 और R12 दोनों का सिर्फ difference है direction. Otherwise, the distance between them, see children, in the diagram, if you see the distance between Q1 and Q2, that is R12, or you can say R21, the magnitude is same. If you talk about direction, one will be from Q1 to Q2 and other will be from Q1, Q2 to Q1. Direction opposite, but the magnitudes are same, right children? So you can write that unit vector R21 equals to minus unit vector R12. Means their magnitudes are same, but the directions are different. So as the unit vectors, the magnitudes are same and only the direction are different. So we can write F21 force on charge Q2 by 1 is equal, but it is in opposite direction to the force exerted on charge Q1 by Q2. So this means that the two charges, they exert equal but opposite forces on each other. That is according to Newton's third law of motion. And let's talk about the direction. The direction, as we know from Coulombian force, the direction is along the line joining the center. So here if you see in the diagram, this is your charge Q1, this is your charge Q2. So line joining the center is what? R12, right? So this is only the direction. देखो direction में तो यही आ रहा था. Direction, you are having R12 or R21, right? So According to the Coulombian force, their force is acting along either F12 or F21, that is along the line joining the center of the two charges. So means they are the central force. So children, this is your Coulomb's law in vector form, and this is the forces between two charges Q1 and Q2, right? Now, if there are more than two charges, then children, what will happen? If there are more than Okay, so children, here we are going to talk about the forces when there are multiple charges, right? Means you are having more than two charges. So this is also known as the superposition principle. So superposition principle is nothing but to find the total charge on one charge due to a number of other charges. For example, this is one charge, and let the charge be called A, and here there are number of charges. So all these black charges, they will exert a force on this charge A. So what is the total charge, so what is the total force on this point charge due to all other charges? That will be given by superposition principle. So superposition principle is used to find the total force on a point charge due to a number of other point charges. So let's see the statement for the superposition principle. The statement for the superposition principle, right? Chalo. So the statement says that when a number of charges are interacting, means you are having a large number of charges, but you want to find the total force on a single charge due to these many number of charges which are all at rest. How you will find out? Simple. You are just going to vector sum the force on that charge due to all other charges taken at a time. Means I'll tell you further when we do the derivation. So suppose what you're having, suppose you're having a system of n point charges, right? बहुत सारे charges हैं आपके पास Q1, Q2, Q3, Q4, Qn charges. All are placed in vacuum, right? And they are placed in such a way that their position vector with respect to origin is R1, R2, R3 and Rn respectively. Now, let me show you the diagram. Okay, so this is my charge Q1. This is Q2, Q3, Q2, Q3 and Q4. Right, beta? Now, with respect to origin, now suppose this is my origin. So this is the position vector of charge Q1 and which is represented by vector R1. This will be the position vector of charge Q2, which will be represented by R2. Similarly, this will be the position vector of charge Q3 represented by R3. That is all are with respect to origin. सब हम origin से लेते हैं. So these all R1, R2, R3, Rn, they are the position vectors of these charges with respect to origin. Right now, what we want to find? We want to find the total force on this charge Q1. Q1 के ऊपर total कितना force लग रहा है? That we need to find. So what will happen? The charge Q2 will exert a force on Q1. Q2 जो है Q1 पे force लगाएगा. That force will be F12. F12 is force on charge 1 due to charge 2. That is F12. Similarly, ये जो Q3 है ये भी force लगाएगा इसके ऊपर. So that is F13. That is force on charge Q1 due to charge Q3. Similarly, ये जो Q4 है, it is also going to exert some force on Q1. So that will be represented by F14. That is force on charge Q1 due to charge Q2. So all you are going to add them, vector sum them, and the total will be the force acting due to the number of other charges which all are at rest. Right, beta? So let's see how we are going to do the derivation. So let's proceed towards the derivation. So according to Coulomb's law, we know Coulomb's law equals to F12, that is 1 upon 4 pi epsilon naught Q1 Q2 upon वेक्टर फॉर्म में लिखेंगे तो बेटा R12 का स्क्वायर और डायरेक्शन that is R12 cap, R12 cap. And we know R12 is what? R12, vector R12 is nothing but it is vector R1 minus vector R2. है ना, ये हमने देखा था ना अभी, right? Vector R12 is nothing but vector R1 minus vector R2. So the same values we are going to put here. That is, if you see it over here, instead of R12, we are going to put here R1 minus R2, R1 minus R2. And upon what you are going to have R12 square. So it is magnitude of R1 minus R2 square, magnitude of R1 minus R2 square, right? Right, you can see, and we know unit vector, it can be represented as vector upon its magnitude. So R12 unit vector is nothing but it is vector R12 upon the magnitude of R12. So R12 क्या होता है? That is R1 minus R2 upon magnitude of R1 minus R2. तो नीचे देखो बेटा क्यूब हो जाएगा, magnitude of R1 minus R2 का cube. So if you turn the slide, you will see that vector F12, it is equal to 1 upon 4 pi epsilon naught Q1 Q2 into R1 minus R2 upon magnitude of R1 minus R2 the whole cube. Right? कैसे आया? Because unit vector R12 is nothing but it is equal to vector R12 upon magnitude of R12. But R12 is what? R1, vector R1 minus R2 upon magnitude of R1 minus R2, right? This already I have told you. So if you put this value, you are going to get this, right? So similarly, this was F12, right? Similarly, F13 भी होगा बेटा. तो F13 की वैल्यू क्या आएगी? चलो फटाफट से लिख लेते हैं. F13 सिंपल होगा 1 upon 4 pi epsilon naught. देखो यहाँ पे Q1 Q2 है तो यहाँ पे आएगा Q1 Q3, यहाँ पे आ जाएगा बेटा, यहाँ पे आपका इसकी जगह, राइट, यहाँ तो आप ऐसे लिख सकते हो दैट इज R13 का कैप अपॉन R13 का स्क्वायर. ठीक है, यूनिट वेक्टर है तो स्क्वायर है, ठीक है, यूनिट वेक्टर होगा तो स्क्वायर होगा, एंड व्हेन यू आर हैविंग वेक्टर तो नीचे क्यूब होगा, राइट? इफ इट इज यूनिट वेक्टर तो नीचे स्क्वायर होगा, एंड इफ यू आर हैविंग वेक्टर तो नीचे क्यूब होगा. सो सिमिलरली आपको nth इक्वेशन के लिए मिल जाएगा, राइट? सो व्हाट यू आर गोइंग टू डू, यू आर गोइंग टू ऐड F1 equals to F12 plus F13 plus F1n. Now something is common. What is that common? Q1 common है, 1 upon 4 pi epsilon नॉट कॉमन है, वो बाहर आ जाएगा, एंड इनसाइड हमारे पास क्या बचेगा बेटा? हमारे पास अंदर बचेगा दैट इज Q2 अपॉन R12 का स्क्वायर, राइट, R12 का कैप प्लस Q3 अपॉन R13 का स्क्वायर इंटू R13 का कैप, राइट? तो बेटा यहाँ पे अंदर जो चार्जेस हैं दे आर स्टार्टिंग फ्रॉम Q2 से लेके Qn. सो यहाँ पे हमने एक कॉमन डाल दिया दैट इज Qi, एंड I विल स्टार्ट फ्रॉम 2 to n. पहले I की वैल्यू 2 रखेंगे, राइट। आई की वैल्यू क्या रखेंगे बेटा 2, तो क्या आ जाएगा Q2 अपॉन R12। देखो आई की जगह 2 लिख देंगे तो R12 का स्क्वायर आ गया एंड R12 वेक्टर, यूनिट वेक्टर। फिर 2 के बाद क्या डालेंगे 3, तो ये वाली टर्म आ जाएगी। 3 के बाद 4 डालेंगे, फोर्थ टर्म आ जाएगी, एन डालेंगे तो दिस टर्म का। सो दिस इज द सबमिशन। इसे क्या बोलते हैं बेटा सबमिशन, दैट इज एडिंग ऑल, right? And if you want to write in position vector form, it is very simple, nothing you have to do, just you have to put here instead of r1 square, you are just going to put, इसके जगह आप वेक्टर डाल दोगे और नीचे स्क्वायर की जगह क्या आ जाएगा क्यूब, right? When it is vector नीचे cube आएगा and when it is unit vector नीचे square आएगा. So this is your superposition principle with which you can find out the forces acting on a point charge due to a number of charges, due to a system of charges.